I agree. Okay, back to work now that the internet has decided to cooperate once more. Okay, so we did the simplest type of stoichiometry problem is with mole. And we can use our chapter 10 materials to extend our knowledge. Our second type of stoichiometry problem is going to be mole to mass. The important thing about recognizing stoichiometry problems is besides mole to mole, all the rest of them are going to be multi-step problems. So it's going to take more than one step in order to get to the right answer. I don't like to write mine out in multiple steps. I use the same fence for all of my stuff. And I'll try to work it both ways to give you the option, because I've noticed some students, it just absorbs a little better sometimes the other way, and some people don't need it, but we'll do it both ways. To do mole to mass, there is a pattern that you're going to follow every single time. In general, this is what my fence looks like. Of course, this is where you're going to have your given. This is going to be the mole ratio. And then the last step is going to be the molar mass. And I'm going to put of the unknown. So if we're going from mole to mass, we're going to start with a given. We're going to convert it to the moles of the unknown. And then we're going to convert from moles to grams of that unknown substance using our chapter 10 skills. So let's look at, let's use my favorite equation. Let's do an example here of, let's go back to aluminum plus oxygen yields aluminum oxide. Like I said, I like to use this one because it's real obvious where our coefficients are coming from. I think it's easier to track down, especially when you're studying and stuff. And let's do an example here. Let's say that we have been given we'll say 17.2 moles of aluminum. And I need you to tell me how many grams of aluminum oxide you make. All right, so obviously, first thing that we need to notice, again, try to put this in your brain. Start processing it now. Accept it. This is stoichiometry, not just plain old mole conversions. I know that because I have a given in one substance and my unknown is of a different substance. Once you know it's stoichiometry, you need to associate right away, I'm going to have to use a mole ratio. Somewhere in this problem, a mole ratio is going to happen. In this case, since I'm going from moles to grams, my mole ratio is going to be my first step. All right, so I'm going to go ahead and I'm going to draw my fence. I am going to put my given, which is 17.2 moles of aluminum right here. If I have moles of aluminum, before I even do anything else, what do I have to have at the bottom? Moles of aluminum, exactly. Since I have moles of aluminum down here and I have moles here, I'm going to have to use my mole ratio at this step because I don't want aluminum. I want aluminum oxide. So the only way I can get from one substance to a new substance is to use the mole ratio. So I have moles of Al2O3. I find the mole ratio components looking at my balanced equation. There are 4 moles of aluminum for every 2 moles of aluminum oxide. Everybody with me up to this point? If you stop right now, your answer would be in moles of aluminum oxide. Do you want moles of aluminum oxide? You want mass. You know how to go from moles to mass of a compound. That was what we just did. So in this case, we're going to extend. So here's my mole ratio. This is allowing me to go from one compound to a different one. And then this step is going to be my molar mass. That is how I convert between moles of a compound to grams of a compound. If I have moles here, what do I have to have here? Moles. And then since this is molar mass, it's going to be the mass of 1 mole. Molar mass is defined as the mass of 1 mole. To find the molar mass of aluminum oxide, I can't just look at my periodic table. I have to use my molar mass finding skills. I'm going to simplify things a bit for this chapter. I think it'll just help us out. We're going to round our molar masses, and it should get us all in the ballpark. So if my aluminum, I'm just going to round it to 27. So there's 2 aluminums times 27, that's going to be 54. And then there's 3 times 16 oxygens is 48. So 54 plus 48 is 102 grams. And I really think that'll make our calculations a little smoother. I'm not requiring it, but if you want to round it to the whole number, I'm good. So now my moles of aluminum oxide have canceled out. I have my mass here, so I will have exactly what I need. So this is what I'm trying to get. And this is what I've got. It's the unit I'm going to be left with. And it's the proper compound. So I'm now going to multiply all the way across the top. 17.2 times 2 times 102 equals. Then I'm going to divide it by the bottom. 4 times 1 is 4. And I come up with 877 grams of aluminum oxide. That's my answer. So I took my new skill and I stuck it with my old skill. Questions? All right, you try this one. Use the same balance. Oh, go ahead.
I put 6.02 where the 1 mole.
That's wrong.
I don't know why.
I don't either.
Why you put a 1?
Because molar mass is defined as the mass of 1 mole. Mass of 1 mole. If that was atoms, you'd be right. Or molecules or formula units. Anybody else? That's a good one. And it's a common mistake. Okay. Use the same balanced equation then, and I'll give you a new given. Let's say you have 5.25 moles of aluminum oxide. And I want to know how many, so our unknown here would be how many grams of oxygen were used to produce that. All right, see what you got. Work it out, and then I'll work it out, and we'll see if we're all on the same page. All right, you can continue working if you're not quite finished. I'm going to go ahead and start working this out, and so you can check yours along. All right, I got 252 grams of O2. What about you? Good job. Yes, you got it? Anybody else? Questions? I'm glad. What you got, Tyler?
1 mole, that mole ratio.
Uh-huh.
Where did you get 2?
On the mole ratio part, if you look at your balanced equation, there are 2 moles of aluminum oxide and there are 3 moles of oxygen. So the mole ratio portion always comes from the balanced equation. This is molar mass, and you have to remind yourself, and I would say it 1,000 times, and I'll say it, but mass of 1 mole. That's what molar mass is. Questions, because those are good ones. Okay. But then the plan for tomorrow is we're going to do mass to mole, mass to mass, and then we're going to introduce liters into the bunch. And then we'll practice those. We'll probably test on Friday over stoichiometry. So make sure you watch the video tomorrow and have any questions prepared for Thursday when you come in.